So this is our front-end boy band, Radek and the Me House, right? So another front-end talk about more or less the new project you're studying, right? So
yeah.
Okay, good luck.
Okay. I'm Michał. With me are Radek and second Michał. We wanted to talk a little bit about building a large-scale JavaScript architecture. First, we will talk a little bit about bad habits and problems we're often facing during the building the architecture, and then we are gonna to show you our way of building it, and yeah, that's it. First of all, what do you think? Something is. Oh, okay. What do you think? What is the most common reaction when JavaScript developers start talking about JavaScript within a group of non-JavaScript programmers? Of course, it's yeah, laughing and mocking at bad parts of JavaScript. Yeah, there is a lot of them, and JavaScript might be pretty funny sometimes. But actually, most of the people still think that JavaScript is still all about writing simple scripts for manipulating DOM and doing just animations and form validations. Yeah, we still use it for that, but it went far beyond that, and its microphone is breaking, I guess. Okay, it went far beyond that, and since last few years we are able to build not only web applications but also backend in JavaScript, and we have a lot of cool frameworks and libraries. Yeah, but even when you look at the GitHub repositories and market demands, JavaScript is probably most popular language right now. Even when you look at this conference on our company, STX Next, we have over 100 Python developers, and 2 of the 4 or 5 technical presentations are about what? JavaScript, yeah. Okay, but what we do wrong? It shouldn't look like that, but okay. What we do wrong? There's many bad habits and problems we are facing during building a JavaScript architecture. Most of them are because some of the people, as I said before, are still thinking it's a simple language for validating forms. On the second hand, there are people who are just amazed about all fancy frameworks, and they are using them without thinking if they actually need it. So yeah, and this is the first problem, and Michał will tell more about it. Yes. It's overall a technology overkill.
Yes, this is one of the problem, overloading project with unnecessary libs or even more complex JavaScript frameworks, where they are actually not needed. Before you install some external libs like jQuery or Modernizer, or use JavaScript frameworks, ask yourself do I definitely need it? Yes. Okay, so let's talk about CSS. CSS also have bad parts, like undoing styles, magic numbers, which is a value is used just because it's work. Dangerous selectors like divs, headers, and page. Hello. And loose class names. It's that isn't specify enough what they actually do. But what we don't have time to write clean CSS, we can use shame CSS pattern. The idea of the shame CSS is that we have totally clear new style sheet just for our hacky code. and there have some simple rules. If it's hacked, it's gone in shame CSS. You must document all your hacky code. What part of code base does it relate to? How does this fix it? And the last part of you must clean your shame CSS when you have some free time. And
yeah, let's get back to the JavaScript. We'll talk about CSS in the later part of the presentation as well. Okay, most classical approach we have during building web apps is multi-page, where for example, Django serves as templates, and we are throwing these templates, these views, JavaScript. Very often, people doesn't overthink, doesn't think deeply about whatever they need, actually Angular or another framework or another template system when they already have a template serve from the backend. And because of that, projects end up with unmindable huge amounts of code. We have a duplicated backend logic on the front-end side, and we have, for example, two template system to maintain instead of one. In most cases, we won't need, actually we don't need another framework, another template system used on the front-end side. It's whatever backend sends us, it's enough. We can just apply simple scripts on top of that, and that's pretty it. We don't need anything more in most cases. Of course, there are certain situations that adding another framework it's a good idea, but it's in most cases it's not. Okay. But what about when we want to just throw, for example, a jQuery to manipulate DOM? It's actually about good structure, good project structure, and that's it. For example, we have a Django application with folder apps, and there's a couple of modules, and JavaScript and CSS structure simply reflects the modules from Django. To the common folder, we can throw build common libraries to the one JS file to limit our request on the backend side, and that's it. That's all we need, actually. Okay. But how about single page app? This is where all the fun starts. This is the hardest part of JavaScript. Yeah, and we are making a lot of mistakes here as well. Mostly because there is so many. Most important thing is choosing a technology stack. Which framework we are gonna use, which libraries, which tools to build everything, which, for example, whatever we should use, LESS or SAS, how we gonna structurize everything and things like that. And it doesn't makes easier the amount of frameworks available for us. It doesn't make it any simpler. So how to choose a proper one? Actually, it's not that hard. In most cases, all the knowledge is over there in the internet, or most importantly, knowledge sharing. First of all, before choosing any framework, just go around in the company. You might ask people, maybe someone actually used it and is able to tell you whatever this framework will work in your project, and what are actually its advantages and disadvantages and stuff like that. Okay, but Besides that, it's a few simple rules, questions we should ask ourselves, and that's gonna help us to choose the right framework. First of all is specific requirements. Think how, for what actually you're gonna use that framework, what do you expect to do from it. The second one is specification availability, which means both how documentation is good and how community is, how big a community is, and how easy it is to find the answer for your problems. But sooner or later you will stumble on some problems. Okay, learning curve with exponential growth. It's about basically chosen technology should be easier for both junior developers and senior developers. You cannot force people to learn complex frameworks, and in most cases it won't work well. Okay, co-workers experience, as I said before, it's always good to keep this in mind. It's always good if you have someone in the company to who you can just go and ask some questions. Okay, of course, keep in mind application growth. Always develop application as it with this rule that it's gonna grow bigger than you think. It's always like that. Okay, maybe we can just go with a quick overview of popular frameworks to show you that all of them has their pros and cons and pluses and minuses. Okay, for example, like JS, very well written, rich internet application framework with good code readability. When you actually see the source of the XJS, it's very well written, perfectly documented. It's something really awesome. It encourages thinking in widgets, and as I said before, it's have great documentation. But always is some bug. Always there is a but. Huge and complex. This is in most cases a deal breaker, because it's really huge framework, and in most cases you won't gonna need it actually. Styles and generated HTML are just as huge as a framework itself, and very complex and sometimes unreadable. And actually it works only for big desktop-like commercial apps. Okay. AngularJS, separation between view and business, thinking components, dependency injection, two-way data binding, which is pretty cool, but actually in most cases you won't gonna need it, and dependency injection is a pretty complex concept, for example, especially for junior developers, and this will cause a lot of troubles. Of course, you are forced to do everything Angular way, and as I said before, complexity. Backbone, some kind of quintessence of frameworks, provides only minimal architecture and leaving a lot of freedom, lightweight, and works for both small and huge apps. Clean code base, easy to understand. You're able to learn just every piece of framework within 1 week max. Okay, but yeah, requires reading a lot of boilerplate. Given freedom confuses a lot of people, because you can find a lot of examples of using Backbone, and each of them is totally different from the previous one. Yeah. Ember.js, complete solution architecture, routing views, same as actually Angular. Performance focused, it's really fast, and it has in his special own way of handling routings. It uses state manager, but you have to go with Ember way again. A very complex code base, and it changes quickly, and documentation is sometimes pretty outdated. Okay, so let's sum this up. Think twice before choosing tech stack. Simple is better than complex in most cases. Don't be afraid to ask coders for an opinion. organize the resources, and that's actually the basic rules of choosing proper technology stack. And now we can go to.
Yeah, it's time for build something, but before that, we're gonna say shortly about some assumptions that we make during the development process of our framework that every developer should keep in mind. So these are the results. First of all, first assumption is dry, so don't repeat yourself. It means that we should reduce repetition of our code and find pieces of code where this repetition is, and export them into separate modules, or simply use inheritance. Next one is to stay organized. So we have to maintain separation of contents, like we should separate contents to business logic, presentation logic, or other specific domain logic. Every concern should have its own place in an application. We also have some principles of modularity, which we decide to present in the context of our modular framework. Our modular framework should be specialized, so each module should have a very specific function, should be sufficient to solve a single problem, and the public API should be simple and clean. Next, independent. Modules shouldn't be tightly coupled, and they should communicate, for example, with facades, and they should know as little as possible about the entire world or neighbor modules. The next one is decomposable and recomposable. They can be tested independently in isolation from other modules. They can also operate independently. So if you remove one non-core component, you will the rest of application should work. And also for recomposable, we should can rearrange the modules to build other app or different version of our application. We can't forget that every module should be substitutable. It should be possible to completely substitute one module with another, as long as it supplies the same interface, and this change shouldn't impact on other modules, because we assume that every module communicate with facades. And last but not least, open-close principle. Our modules should be open for extension, but closed for modification. Yeah, and so yes, we have our assumptions. Let's see what is in our case study. In our case study, we want to build a component-based framework for development modular JavaScript application. Each component can be used separately as a widget. Widgets don't know about where where they will be displayed. We have also decoupled modules. They are not tightly coupled, and the communication based on event bus. And we decided to use Backbone.js because of that, because it's simple for other developers. Yeah. So when we think about technologies, I mean that we use Backbone.js with Marionette as a code base for our framework, SAS for building modular CSS, Gulp as a task runner for building and development purpose. And we also use NPM as a package manager for downloading dependencies. And also, yes, we don't use Bower. Yeah, we also use Browserify as a common JS implementation for packaging and building application in our modular way. Okay, so show me more. Yeah, we want to stay organized, so we want to. I will show you folder structure of our framework. We have two main directories, JS and SAS. JS contains, as you can think, scripts, JavaScript code. App.js is an entry point for our application. Common directory contains utils and core modules that are used by components. Components contains specific views and some features like app router that overrides standard routing, and also we have DAO, so data access objects. These are the models and collections grouped by domain-specific logic. Yeah, and we've got also SAS. SAS contains components that are grouped by that are connected with components from JavaScript. We have also themes for custom view of our application, and vendor directory for external libraries such as normalized CSS or other. Yeah, we saw the structure, but how does it really work? So first of all, app.js initializes core modules, framework dependencies, and it gets config JSON file with configuration. Core module initializes routing according to config, and some specific views and DAO files. Only the critical in context of good user experience. So we initialize only the main views that are displayed first. So the second diagram shows us how our presentation logic works. And the router calls to event bus to show some specific view, and initialized views listens for events and are registered for responses. And when any view get an information about show me yourself, or show me some view, if for example it's initial view and it is viewport, it knows where it should be rendered, so it render itself. But first, if it has child views, he calls to event bus for show other views. When other view get this information, he doesn't know where should be rendered, so he called to event bus, and he gets a reference, DOM reference to render itself. So initial view response for that request about where it should be rendered. Yeah, so that's all from me. Thank you.
And now, what's under the hood in the models? Actually, let's take as an example many. We have fewer regions, header content, and many have some kind of layout and, of course, items. And this is examples. Actually, this is actual structure in our project. So we have a many.js file initialize whole module, and also initializer keeps a whole logic responsible for triggering module, initializing it, disabling it, and destroying it. Many view handles showing a main view, many layout. It grabs a template and renders it based on events coming from event bus, when the other component will tell the view where it should be displayed. Of course, there is many items, so the same rule here. Here we have a template and a view file which handles the template. Basically, many based on, for example, backbone collection. For each item in a collection, it renders many items based on that template. And actually, basically, that's it. This is the example code. Of course, it's simplified for demo purposes. We have this. It is written in a CommonJS style, so we are using CommonJS modules. We have all those requirements like backbone and vendor libraries. Of course, we have a logger, register for init method. Of course, initialize whole module. Register for commands is responsible for registering a module for event bus commands. For example, hey, now you should initialize yourself and render your views. And yeah, basically that's it. Of course, styles structure reflects the module structure, and Michał will tell more about it.
Yes, like Radek said before, for building CSS model, we use SAS compiler with Compass. We also use BEM methodology. BEM is a smart way for naming our CSS classes to give them more transparency and meaning. The meaning convention follow these three patterns. Block represent a higher level of abstraction or component. Block element represent a child of this block. And block modifier is a different version of this block. It means there maybe is clicked, is hover, or something like that.
Yeah, and back to me. There is a reason we built everything in modules, because one of our assumptions in project was to make actual modules that we built to being reusable across the other applications, in this case for banking applications. So that's why we used CommonJS modules, and that's why we're using browser verifier to build everything. Because okay, what we do, we are able to build each of the modules as separate package and publish it, for example, using Jenkins in a repository, and the other project just installs it as using npm, like that. So we have a source here shown before. This is the SAS source. So we are also pulling the SAS sources to publish also styles of the modules, and we take these ones. Browser verifier is crawling across the files using the require methods, and depends on config. It excludes external libraries. They are not bundled in the final package. Instead, they are pasted in the package JSON, also generated by our build scripts. So browser UI crawls on these require methods, and the output we get something like this. Many.js, this is a bundled package. SAS sources, they are not compiled into CSS because applications that are gonna use it probably we'll want to replace some values there with variables. So yeah, so I mean variables with values, and yeah, this is the SAS. And here there's a package manifest where are module informations and all the dependencies about external libraries that were not bundled into that package. And that's it. Thanks to that, we can publish any module as a separate package, just like that, and pull it with as a npm dependency in any other project. And yeah, time to wrap everything up. So everything we said, can we also close as a few simple rules during creating our architecture, not necessarily the way we show here, modular way, but in any other way also. So first of all, you have to always make a solid project assumptions and specifications. You just basically need to know what do you want. And think twice before choosing your technology stack. Remember, simple is often better than complex. That's true. Don't be afraid to create custom tools, but also avoid reinventing the wheel. So going with a ready solution like AngularJS or Ember.js is not always the best way, but also stay focused and remember not to write something that is already written. And of course, as we said before, don't be afraid to ask coworkers for advice. Yeah, in most cases, actually, of course, sometimes we need a quick solution, and Angular or any other ready-to-go framework is a proper solution. We are not telling that they are bad or something, but sometimes it's good to write something on your own, because yeah, you can be amazed how far you can go with it, and how and you just simply start thinking for yourself instead of using something that someone told you to do. And yeah, that's it. Thanks for your attention. I don't know, I guess we don't have time for questions, or we do?